Welcome to my class once again. Today we would like to continue with forces, and we have inclined plane. So we are going to be dealing with forces on inclined plane. If you find my videos interested, and you can share or subscribe to my videos and follow me up anytime that you're free. Now, if you want to talk about inclined plane, an inclined plane is simply a part in the system where there is an angle theta, or there is an angle to the movement of an object. So if we consider the diagram that I have here, this is the angle, and this surface is representing the surface on which there is going to be either an upward movement or a downward movement. If I want to bring this object here, now this object has its own mass, and anytime you have an object on a plane, be it horizontal or inclined, the first thing that we want to know is that the object will have a normal reaction. And remember, the normal reaction is always perpendicular to the surface on which the object is moving. That is, the normal reaction should make an angle of 90 degrees. And the weight of the object is always acting directly downwards. If you look at the diagram here, you realize that for inclined planes, the normal reaction and the weight are inclined at a certain angle theta. If I elongate this line downwards, you realize that this is the angle theta, and the angle theta here is always equal to the angle of the inclined plane. So this theta is the same as this theta. If I want to resolve my weight to get a horizontal component and a vertical component, it means that I have to draw a line so that the line becomes parallel to the movements of the object on the plane. So if I draw this line to be parallel to the movement here, you realize that this angle here is opposite here. So this component becomes nj sine theta, and this line, which is also adjacent, becomes mj cos of theta. So this side, or this aspect of the diagram, is the cos aspect, and this aspect of the diagram is the sine aspect. Looking here, you realize that since the weight is directly downwards, these other vectors will have to move in such a way as to meet the weight at this point. And therefore, if there is going to be a downward movement, then the component of the weight that is moving downwards will be mj sine of theta. Remember, m is our mass and j is acceleration due to gravity. Now, if this system is a rough surface, it means that there is going to be a friction F that will oppose the movement of the object on the horizontal surface, which is inclined here. Good. Now let us write our equations from the diagram that we have. First, we can say that our R, which is our normal, is equal to mj cos of theta, equation 1. And then we can say our frictional force F is equal to mj sine of theta, equation 2. We have already learned from our previous class that our F is equal to mu R, where mu is representing our coefficient of friction, and therefore mu becomes equal to F over R. If I substitute these equations for F and R, I'm going to get mj sine theta all over mj cos of theta. This will cancel this, and finally you have mu to be equal to sine theta all over cos of theta. Therefore, mu becomes equal to tan of theta. So another relation for our coefficient of friction is tan of theta. Now, aside that, let us take note of these equations here. If this is the angle, then we can say that this side, which is adjacent to the angle, let's represent it by S, and this side, which is opposite to the angle, let's represent it by Y, so that this side becomes the hypotenuse H. So from this same diagram, I have X, I have Y, and I have H representing this side. You can see from the diagram that sine of theta will be equal to Y over H, and then cos of theta will be equal to X over H. In some situations, or in some cases, you can see that from R to be equal to mj cos of theta, we can decide to come and replace the cos theta by this equation here, so that R becomes equal to mj multiplying x over h. So when you are not given an angle but you are given any two sides, you can either use cos theta or sin theta to replace the angle, so that this can also be used as an equation to find the normal reaction. Please kindly take note of these equations. And then also you have F is equal to mu R. We can say that F is equal to mu multiplying R, which is equal to mj cos of theta. So we have all this equation representing the friction, which is mu mj cos theta, and then friction to be equal to mu R, where R is the normal reaction. We are going to move on to solve a few questions on this topic so that we understand it better. Our first question here: an inclined plane of inclination 45 degrees has a mass of 20 grams resting on it. Calculate A, the coefficient of friction of the plane, and then B, the normal reaction of the plane if the whole system is in equilibrium. Now, for a physics question, the first thing you have to do is to draw your diagram. So we have our diagram here. There is friction, there is a normal R, there is mj cos theta, there is mj sin theta. But we have already known from the other equations that our mu is F over R, which is equal to mj sin theta all over mj cos theta. Therefore, mu is equal to tan of theta. So for our first question A, then the coefficient of friction mu here is equal to tan of 45 degrees. And we all know tan 45 degrees is equal to 1. Therefore, the coefficient of friction mu will give us 1. Then the second aspect of the question, you have been asked to find the normal reaction of the plane if the whole system is in what? Equilibrium. You can see from the diagram that R is equal to mj cos of what? Theta. So R becomes equal to, the mass is 20 times 10 to the power negative 3. Since it is in gram, you have to change it to kilogram. Then gravity is 10. Then you have cos of 45 degrees. So cos 45 degrees will give you square root of 2 over 2. And when you multiply the whole through, you are going to get 0.1414 Newton. So you have our normal reaction to be 0.141 Newton and our coefficient of friction to be 1. Please, this can be done only when you draw the diagrams right and you are also able to recollect the equations that you need to solve the question. Thank you. We'll move on to our next question quickly. Okay, with our second question, we have a body is released from rest at the top of a plane inclined at 30 degrees to the horizontal and 4.0 meters high. If the coefficient of friction between the body and the plane is 0.3, calculate the time the body takes to reach the bottom of the plane. First, our diagram. And we are saying that the plane is 4 meters high. So from here to here, we have 4 meters. Good. Now, what I would like us to do is to write all the equations that are possible here. Once it has a coefficient of friction, then it means that there is going to be our F over here. So the first equation we have R is equal to mj cos of theta. Let's call this our equation 1. Then we have F is equal to mj sine of theta. Let's call this equation 2. Now, since the body is moving or the object is moving, it means that the object will by all means have a resultant force, and that resultant force can be written from the equation m of a or ma to be equal to mj sine theta minus f. Better still, we can write it as ma is equal to mj sine theta minus f. We remember that f is equal to mu mj cos of what? Theta. So from here, we can say that a is equal to j sine theta minus mu j cos of theta. This is our equation for acceleration. Good. So let's call this equation 3. Then from the diagram, we can also see that sine of theta is equal to 4 all over the distance x, where the distance is representing the movement here between, or the movement on the surface of the plane. Okay, so if we want the distance s, then the distance s becomes equal to 4 all over sine of the angle, which is what, 30. So the distance x becomes equal to 8 meters. So now these are the informations that we can get from the diagram. After getting all this information from the diagram, then we can move on to solve the question.